Hi, hi Ankit, good morning.
Good morning. I think we can get started. So we are going to discuss today uh, in SQL Server indexes, database indexes, right? We will discuss how they work and how they can be used to improve the query performance. Okay. So we will see in detail. First, we will understand what is index graphically, and then we will jump on to create some tables, create indexes, and see how it can improve performance. Okay. Let me share my screen. Let me know if you can see. You can see my screen, right?
Yes, sir.
Okay.
Yes, Ankit.
Okay, great. Okay, so what is the index? First, let's try to understand what is the need of index, right? So let me open Paint and I will just explain that. Okay, so let's say, so when we say data is stored in our database, it is basically stored somewhere physically, right? In a disk. right? In a disk, it will be in data pages, but let's consider this is our disk, okay? And data is stored on this disk, okay? So this is our disk. Now, what happens is when you insert the records, you say insert into table and you are inserting records. There are millions of records in tables, right? What happens? So data will be stored somewhere. Let's say I have an EMP table, right? So let me put that. This is my orders table. We are talking about orders, right? So this is my orders table, right? Orders table. Okay. Now there are hundreds of orders coming, thousands, millions of orders will be there every day. Consider this is Amazon's orders table, right? So what will happen? On the disk, all the orders will be stored, right? So let's say this is my first order. So there is order ID 1, okay, and customer ID 1, okay. So this is here, right? Now there will be next order, let's say order ID 2, and this is by customer ID 2, okay. Now there will be millions of order, let's say, in between this, and this order is not mandatory, right? By default, let's say you can have order 3 here stored in physical disk and order 4 here. So there is no guarantee in disk where the order IDs will be stored. They will be stored randomly, okay, by default, if we don't give any index, right? So what will happen? Let's say customer ID 1 again, and we have a order 3 here and customer ID, right? Like that, we have millions of record. So we have order 100,000 something, okay. So in between there are millions of records here, right? Now you run a query in your system, right? You say give me details of order ID 5000, right? I need details of order ID 5000. So your query is select star from orders where order ID equal to 5000, right? Now database doesn't know that where exactly is order ID 5000. So what it will do? It will search all the rows. So if it has 1 million row, it will just go from start and start searching for order ID 5000, and it will scan full table, right? If there are 100,000 records, it will scan all 100,000 records to give you order ID 500, right? Or let's say your query is select star from orders where customer ID equal to, let's say, 100. Then again in this case, it will go through all the records, all 100,000 records, right? It will go through all 100,000 records because customer ID 100 can have multiple orders, right? One customer can place multiple orders. So it will go through all the records, 100,000 or 1 million, right? And it can be very costly, right? So what we can do? So one thing we can do is we can sort this data, right? So instead of data in a random order, what if we sort it, right? If we sort it, it becomes easy. So if the data is sorted, how it will look? So let's create another, this one. So now what will happen if it is sorted? We will have order ID 1, then order ID 2, order 3, order 4, order 5, right? In that way, we will have order, whatever orders are there, right? Now your query says, give me all the orders where order ID is, let's say we are going with order ID 5, right? So it knows that data is sorted. So it will start from the top 1, 2, 3, 4, 5. It will come to 5 and will check one more record if in case they are duplicates, right? So because it is sorted, all the 5s will be together, right? So it will just come here, give you the 5, and it will not look for the rows after that, right? If it is not sorted, then again it has to go through all the records, but because it doesn't know, data is not sorted, so 5 can be anywhere from top to bottom, right? But here, because data is sorted, it will just stop the moment it sees that order ID 5 is there, so it will not go through all the records, right? But the another problem with this approach is, so this is there, we have to sort the data, that is clear. But another problem can be that, let's say you are saying give me order ID equal to 100,000. Instead it has to go from 1 till 100,000, right? So what happens? So this is a linear search, right? If I'm doing this way, just sorting the data and starting from top to bottom, it is a linear search, but database doesn't do the linear search, right? So when you create an index, data will be sorted in a B tree or bitmap structure, right? So data will not be sorted in a data will be searched in a B tree structure. Okay, so I'll just quickly show you how actually data will be stored. So this is an image. Okay. So if you see this image, there is a root node. This is a root node, and these are the pages basically. So ultimately, data is stored in a pages in data and SQL Server, right? So each page will be 8 KB. So whatever those can come in a page will go. Okay, so this is a root node. So let's consider that you have a table which has 1200 rows. Okay, so this is a root node, and this root node will have information that 1 to 400. So let's say I created index on order ID. So this root node will have information that 1 to 400 order ID will be in this branch, right? 400 to 800 will be in this branch, and 800 to 1200 will be in this branch, right? Now again, these are intermediate rows. So this is root node, and then we have intermediate road. Now intermediate one will have information about that 1 to 200 will be in this data page, 200 to 400 will be in this data page, and similarly, right? So it will traverse like this. So if you are searching order ID equal to 100, so it will go here, right? So it is able to skip all this record, right? It will go here, and again it will check, okay, 200 is where there. So it will just go to this data page and get you 200. So it will scan only 200 rows, right? It doesn't have to scan all 1200 rows, right? So in that way, database is able to skip rows that it has to scan. It will scan only limited rows, right? Wherever the your row is as per the database, it will traverse through the B tree and give you the result, right? So far, is it clear? Is it making sense? Anyone?
Yes.
Okay, great. Okay, so this is how it works. So for example, let's take an example of a book. Let's say I have this book, okay, and this book has 347 pages. Okay, I say in this book I have a problem called teachers. Can you search it? If you don't have this index, right? So what you will do? You will just start searching it from top. Go, right? And the moment you see that teachers problem, you will find it. But it is a lengthy process, right? You have to go page by page. Let's say you don't have control F option, so you have to go page by page, page by page, and you have to search, right? And similar thing database had to do here in this case when data was not sorted or we didn't have index, right? If we have index, what we will do? If we have index, we will just go to the index, right? And we will say where is teachers. You will find teacher. Teacher is page number 53, and I can directly go to page 53, right? And there is no problem. I will just directly go to 53 and I will find teachers, right? This makes life easy. Similarly, in database also, if we create index, so there are two kinds of index. I will talk about it. But if we create index, we can just go to the go to the index and see where is the row, and we will search it. Okay. Now there are two kinds of index. One is clustered index, one is not clustered index. So what is clustered index? So it is like this. Let me open one Excel. So let's say I have an employee table. Okay. And in my employee table, I say employee ID has clustered index, right? So what will happen when you create a clustered index on a column? Okay. When you create a clustered index on a column, the data physically will be sorted and stored in the database. Okay. So we have employee ID, employee name, salary, let's say. Okay. So when you insert a record, the data will be sorted. First, it will be 1, 2, 3, 4, 5. It doesn't matter you insert data in what manner. You may insert 5 first and 3 later, but data will be sorted in the database. If you have created a clustered index on employee ID, right? And we will have name and some salary. Okay. So basically, if you see in the disk, data can be sorted only one way. So we can have only one cluster index. I cannot create a cluster index on employee ID as well as employee name, right? It will not work because data either I can sort by employee ID in the disk or I can sort by employee name and store. I cannot sort by both and store, right? That is not possible, right? So there is a concept of non-clustered index. So what happens? Let's say you are creating a non-clustered index on employee name. Okay. So now what will happen? A new structure will be created in the database, right? Let's say the cluster, the name is IDX customer. I created this index with name IDX customer, right? So what will happen? A new structure will be created in the database, and that structure will have all the values of this customer name. So I created on employee name, sorry. So it will have all the information of employee name. Okay. So whatever employee name are there, I have A, B, C, D, E in a sorted manner. Okay. And it will have address of each row. Address, right? So it is very similar to in the book we saw the index, right? So we have the heading, right? In this book, if you look at it, we have the heading and the page number, right? Page number is nothing but an address of this. Counting Fish address is 172. Similarly, I'm storing all the values of employee name, and for each row, what is the address in the database, right? So now if you search, if you run a query, select star from employee where employee name equal to D, right? What will happen? Instead of directly going through the table, what it will do, it will check, okay, there is an index on employee name column. It will go here, does a binary tree search, right? In this similar way, it will do binary tree search. It will find D, and along with D, we will have an address, right? It will just go to this address and get you the result, right? Okay. Similarly, if you say, give me employee where employee ID is B, so it will just again go here. Instead of going in this table directly, database will know, okay, there is an index on employee name, so I can use that index. We will see in action, but I'm just telling, if there is no index, it will go through full table in scan, right? It will check all the records. But database knows, okay, I have an index on employee name and I can use it. So it will go to the index. Just go to the B as soon as possible using a binary tree search and give you the, it will have address of this row where B is present, and it will give you the data, right? So this is how index works basically, right? Now let's see in SQL Server how we can understand it. Okay. Let me create a table, create table, let's say EMP. Okay. And we have, now another thing is, one more thing is, when you create a primary key, right? When you create a primary key on a table, by default, clustered index will be created on the primary key. So whatever primary key you give, the data will be sorted in the database as per the primary key because it is a clustered index. Okay, so let's see that in action. So I will say this is a primary key. Okay, and name vector. Let's create this one. Let me create it without primary key and then I will show you something. EMP is already there. Okay, let me insert some data in this. Insert into EMP index values 1, comma. Let's say 4 records. I will insert 1, then I'm going to insert 3, then I'm going to insert 2, and then I'm going to insert 4. Okay. Rahul. Okay. So I will insert these rows one by one. Okay. So let's. Okay, 4 rows affected. So if I say select star from index, execute, right? So if you see employee ID 1 I inserted first, then 3, then 2, then 4. So this is how data is stored in the database as well, right? Now what will happen? What I'm going to do, I'm going to, okay, also if we see this table, let me refresh this. Okay, and I will go to EMP index, okay. And if I go to indexes, nothing is there as such, and there's no key. We did not create any primary key as well. And data is stored as I inserted, right? I inserted 1, then 3, then 2, then 4. Let me drop this table and create again with the primary key. So I will say employee ID primary key. Okay, and I will create it again. Execute. And let me refresh this one. Okay, so if you see, there will be one primary key, okay, and there will be one index as well, which is on primary key. So it is basically same, right? Because the moment I say primary key, the clustered index will be created on the same table. So it is the same constraint basically, right? It is showing clustered index, right? You see here clustered, right? So it is a clustered index. Now let me insert this data again. Now I will do select star from EMP index. If you see here, the data is sorted, right? Earlier, when there was no primary key, the data was in the order I inserted it, right? But now data is sorted. Even though I inserted 3 first and then 2 later, in the database it is still in the sorted way, because the moment I create a clustered index, right, data is sorted in that manner only. Okay, is this fine? Why data is getting sorted? Because I have created a clustered index. When I create a primary key, the clustered index is by default created, or we can separately also create. I will show you how, but it works like that if you give primary key, the clustered index will be created, and clustered index will be only 1. Okay, now what is the syntax to create indexes? Okay, so if I say create index, and I can,
And
yes,
if 2 columns having primary key, so then it will sort for both the columns.
yeah, if you are saying composite key, right?
Yes.
We can have only one primary key in a table, but primary key can be a composite key, right? Combination of employee ID and employee name, right? That's what you are saying.
Yes.
Yeah, so data will be sorted on both. Right, you are right. So first it will, like order by we do, right? Employee ID and employee name. So it will be first sorted on employee ID, and if there are any duplicates, then it will go to employee name and sort it.
Okay.
Yeah. Okay. So this is a create index. Okay, and then you can say index name, any name you can give, idx underscore first something. Okay. On, and then you have to give the table name. So let's say I want to create an index on this table. And the column name, on which column you want to create. So I want to create on employee name, let's say, right? So here I can specify I want clustered index or non-clustered index. Let's try to create it on clustered index. Let's try to create a clustered index, idx underscore customer on this. What is the cannot create more than one clustered index, right? So if I run this, cannot create more than one clustered index on table. Drop the existing clustered index before creating it. So that's what I was telling you. We cannot have two clustered index because in the database, I can sort and store the data only in one way. I cannot sort on employee ID and also keep it and separately on employee name also. We don't want to keep two copies of the data, right? That is not a efficient way. So we can create only one clustered index. If you want to create index on the employee name, you can create a non-clustered index, or you can drop this primary key constraint, or you can drop this index, and then you can create clustered index on employee name. But for now, we are going to create non-clustered index, right? So if I do this, the non-clustered index is created, and if I refresh this one, we will have one more, right? IDX name we created. It is saying it is a non-clustered index. Okay. We have a view actually, procedure, a system procedure. It is execute sp help index, I think. Execute sp help index and the table name. So if I run this, so this procedure is a system procedure. It gives you the information about the indexes in a table. It is taking some time. Okay, so when you run this, it will tell you all the indexes. See, these are the two indexes, right? So this is the primary key that was created by default when I say primary key, and this is the one I created just now, IDX name. It is saying it is non-clustered index, right, on employee name, and this is a clustered index. We will talk about other things, unique, non-unique. But if you see, we have an employee ID. On employee ID, we have a clustered index, and on employee name, we have a non-clustered index. Okay. Now let's see this in action. So I have created a table. Select task norm. I'll give you a script for this orders underscore index. It has more number of rows so that we can see the impact of indexes. It has around 100K rows, right? 999,400. So I have done just what I have done. I have whatever orders data I have inserted it at 100 times. So we had 999,400 rows and we have 00, right? So it is almost 100K records. Okay. Now let me show you some of the records because I have inserted one more column. So if you see, I have created one more RN column, which is a unique column, primary key. Okay, because row ID will be repeating because I have repeated the data, but this row number will be a unique key. So if I do max of RN, it will be equal to 99940. So this is a unique column. Okay. And if I go to this table, orders index. Okay. Do I have a key? It is running slow today. Okay, so if you see there is an index already created. I have created an index, unique non-clustered index. Okay, and there is no key. So let me delete everything. Delete this. So if I have to drop index, what I have to do? I have to say, just copy this. Okay, and I will say drop index. And then index name idx underscore rn, right, on this. So from this table, this table, I want to drop the index. So this is the drop index. Okay, and let's see, do we have anything else? Should I just refresh it? Indexes, there's no index, there's no key. Okay, so currently there is nothing there in this order index. Basically, there is no primary key and there is no index I have created. Okay, and let me try to do some filtration. So I will just select star from orders index where rn equal to, let's say, 100. And I'm going to run this. Okay. So now it will go through all the records and give me where row number equal to 100, right? Let me kill it for now. I'll just say execute, show me estimated execution plan. So you can just select the query and press Ctrl L or right click. It will show you the estimated execution plan. Okay. Oh, there is some issue today. It's running very slow. Let me restart it. I think there is some issue. Let me close this.
Ankit, one thing, like while you are restarting it, so when we were giving ranking to employee table, like in that time where we got the employees that have same salary, that particular time we saw that we saw the order of employee IDs, and you told us that, oh, this is basically the order you have saved the employee table, like
Right.
so it means that time we were not having any primary key assigned to the
Table, right?
table, right? Okay, so in other scenario, if we already assign the primary key, it will be in a particular order, like ascending or descending, right?
Right, right.
Yeah, okay.
Yeah. Also, when you create an index, you can even specify you want ascending or descending here. So if you say ascending, the data will be sorted in the ascending order. If you say descending, it will be sorted in a descending order. So that can also be done.
Okay. But then what is the difference between non-clustered and clustered? Because in non-clustered, I saw we are just sorting the data, not any, doing nothing, just sorting it into a particular order. Like in clustered, sorry. In clustered, if you see, we have just sorted in the employee ID in ascending order.
Right.
But in clustered, basically we are particularly assigning an index, like we are creating a key value pairs. Okay.
Right. In non-clustered index, we are creating a key value pair. Right.
So basically non-clustered is better because we have indexes, but in the clustered we have just we are just sorting. So but although it has to sort all the data, it
Right.
has to go all the data one by one, and then it will give the results.
No, so this will also do a binary tree search only in case of clustered index as well.
Okay. So basically it is creating a plan at the backend, basically computing the
Right. Right. So in both the cases, data will be in this clustered index, data will be sorted within the disk on that column if I have created an employee ID, but search will be binary search, and it will be as per the data pages what we discussed, right? Data will be sorted in that way only. Okay. But in non-clustered index, we are creating a separate key value pair, and for each of the value, we have an address. So this is a key and this is the value. Value is nothing but the address of this A, right? Where is A exactly, in which data page it is there on the disk? You will have that address, and you can go directly to that database and fetch the result.
Yeah. Okay.
Ankit, can you show that a T diagram for the non-clustered index, as in put it?
No, this is
Actually how that,
called
you know,
clustered index and non-clustered index both. So what happens? Data is stored in your this leaf nodes, right? This is the
Yeah.
top bottom, right? So what happens in case of clustered index? This structure is there in the disk itself. Okay. So data is stored. So let's say you created on customer ID or order ID, right? So data will be stored in the data pages at the bottom node, and you will have this all the routes telling you that which way you have to go. Now in case of non-clustered index, instead of rows exactly, data rows, you will have a key value pair, and that key value pair will have value and the address.
Okay, yeah. I mean, so let's say instead of 1 to 400 there, that it shows that order belonging to 1 to 400 stays in that data page. It would say, I mean, how it defines, what exactly it defines is my question. As in, like, does it define that? What does that key indicates, and what for?
In the non-clustered, right? In non-clustered.
Yeah, in non-clustered. Yeah.
Yeah. So in non-clustered, so let's say you created on employee name.
Okay.
You created a non-clustered index on employee name. Okay. So this is a key and this is value. Okay. Key will be all the values of your employee name. Right. So for example, 1 to 400, it will be, let's say this is a alphabet, right? So it will say from A to C will be here, maybe, right?
Okay.
Okay. And you will have address. So on the leaf node, on the bottom node, you will have address. So you will have key A, that A will be here, let's say, and along with A, you will have the address of that in that index. So address is nothing but it is a physical address in the disk that where this A is present in this table.
Okay. So isn't it in some cases the clustered is more efficient than the non-clustered because it has to kind of identify or
right. Clustered is more efficient, but the only limitation is I can have only one clustered index. What if I want to create more indexes? Right.
Okay.
So in clustered index, it can directly go to the table and do it. Right. It doesn't have to. So in that case, in this case, it has to first look at the index and then go to the table. Right. Do a lookup.
Exactly.
Right. So it will be slow. Clustered will be faster because data is already sorted and it will be quick. It doesn't have to do lookup or something.
Got it. Only in case of, let's say, when we usually have I mean, in our, if the query is bigger and we have multiple conditions in the where clause,
right,
we could put that under the non-cluster index so that it makes easier search.
Right. So in this case, let's say you have two queries. One query is you want to have a filter on employee ID. You have some queries where you have to run employee ID wise, right? You have another query where you want to search by employee name, right? So if you create
Yeah.
index on employee ID and put a where condition on employee name, it will not be able to use the index, right? Clustered
Yeah,
index. So you
makes
can create
sense.
a non-clustered index on employee name. It is better than doing a full table scan.
Got
Right.
it. Yeah.
And Ankin, while we are providing, that clustering, so not talking about the saving data in the backend. So as you said, it will automatically basically save the data based on some structures. Then the round robin and that hash distributions comes into picture when we are providing that clustering. Because let's say we are doing non-clustering based on the column name, like the employee name and the same employees. Let's say we have employee name Ankit, and it is we have 5 employees naming Ankit. So
Mhm.
it has to save somewhere, right? Say Ankit in a particular disk. Then how the system will find, okay, this Ankit we are referring. So then I think that distribution comes into picture. Like, okay, we have hash distribution and we are saving it based on this in a particular disk like this. Is it? I'm not sure.
1 second, and let me open and show you. 1 second. Where did I create it? Here only now. This is the one. Okay. Can you ask your question again? I was just looking for the file actually.
So I was asking, when we are creating like any non-cluster index,
Right.
in non-cluster we are providing a column name.
Right. On which column I want to create an index. Right.
Now we have employee name Ankit,
Right.
only Ankit,
Hmm.
and Ankit, and let's say I'm searching, okay, where name is Ankit.
Right.
Definitely that the Ankit name will be saved in a particular partition, right? At the backend. Same Ankit, like 5 Ankit we have, the same Ankit
Right.
will be saved at a particular same location. Otherwise, it has to go to a different partition and have to search. So then the distribution technique will come into picture, like that round robin has distributions. Then it come into picture, or previously it come into picture when we are creating a table.
So we are not talking about round robin. We are not talking about partitions here. We are talking about indexes.
Yeah,
Right.
yeah, that is fine. But at the backend, it is going to save the data. So then we are
Right.
distributing the data, right?
So data is stored. So again, if you have created a clustered index, right, data will be stored based on the employee ID. So let's say this is how it is stored for now, right? So let's say this is Rahul and this is Ankit. Okay. And now you created an index on employee name, right? So you will have A, you will have in the sorted way, right? Ankit. And you will have D, E, Rahul. Like this is how the index would have been created. A new object in the database, index IDX underscore employee name would have created, and it will have this information. The key value means the name, the values of the column, and the address, right? The moment you say, give me select star from employee where employee name equal to D, it will do a binary search on this index and reach to the Ankit, get the address, and go to this address and get you the details. Even if I have multiple Ankit in this table, right? So let's say we have another Ankit. So multiple Ankits will be stored with address, right? So it is not a unique index now. It is not a unique index because the values are repeating, right? It is non-unique index. So, but both the Ankits address will be stored. So it will say, okay, both the Ankits are there. It will get the address and give me both of the Ankits.
Yeah. Okay. Got it.
Okay. So let's see if this is running now. Let me open a new query. Okay, this is fine now. There was some issue, I think. Okay, so we have around 100,000 records, and if I go there and do a query plan, you see there is a clustered index already created in this table, I think. Let's drop this. I must. Orders, index. Keys. Okay, nothing is there, right? Okay, nothing is there. So if you see here, I think something is.
The database, I guess, it's running in master. Did you create it over there?
I think I created it. Let me do one thing. I will create the table again. Okay, let me open file. This is the command. Let me create it again. So I'll just drop this table. Drop table. Yes. Okay. I'm going to create this table again. What I'm essentially doing is, if you see, I'm writing a query from orders, okay, and then I'm doing a cross join. If you see, I am not giving any join conditions, just comma and top 10 star from orders, right? Top 100 stars. So what will happen? There are 999 rows in this table, orders table, and from B I will get 100 rows. So it is doing a cross join, and we will have 999 into 100, these many rows. So if you have to produce some large data, you can just do a cross join, right? So this is a good way of, so let's say you want to do some performance testing or something, you can always do a cross join without any join condition. So it will just replicate. And also I have generated a row number so that I will get a unique value, and I can use this as a primary key later. Okay. So this is also one use case of cross join to generate huge data for performance or testing or whatever. Okay, this is created and we have 999,400 rows. Okay, so this table we have, and then let's run this. Select start from orders index where rn equal to 100, and I will just say display estimated execution plan. Okay, so if you see here, it is saying a table scan, right? Because there is no index in this table. I am saying rn equal to 100, so it is going to check all the 100k rows and give me the result, right? So if you come here, it is saying, if you look at this row, number of rows to be read. Are you able to see this? I'm not able to take my cursor there.
Yes, we can see Ankit.
Right,
Last
it
but
is saying
4.
estimated, yeah, last but 4. Number of rows to be read. So it is reading all the rows, right? 999,400. Correct? because there is no index. So it has to go through all the rows and give me one record, right? And what is the total cost? Total cost is, if you see, total subtree cost is 43.0946. So basically it is the total cost of all the, when it is going to the binary tree, what is the total cost? It is 43.0964. So I will just note it down. 43 dot something. And it is reading all the rows, 999,400, right? Now let me create an index on this table. So I will say create index. And I'm going to create it on IDX RN. Okay. On, this is my table. And this is RN. Okay. I'm going to create a non-clustered index for now. Okay. So this is done. And let me run this. Okay, and I will run the execution plan now. Okay, if you see, it is doing an index seek now. Earlier, it was doing a table scan, right? But now it is doing an index seek. And if you look at it here, it is saying number of rows to be read is only 1, right? Without index, it was reading all the rows, 999,400, right? If you see fourth last row here, estimated number of rows where my cursor is, it is only 1. So it is directly able to utilize the index and go to that row directly instead of going through all the table, right? And we look at the subtree cost. It is just 0.006. Earlier it was 43 point something. So you can imagine, if you have a huge table, how much performance impact it can make creating an index, right? So it is from 43 to 0.0065, right? Almost negligible in this case. And the more this is 100K is nothing. When you have millions of records, this index can drastically change the performance of your query. Okay. Is this making sense here?
Yeah.
Okay.
Ankit, one thing here on cost, like what actually, how we are calculating cost and how it matters. Basically, I heard a lot. Okay, this delete operation is very costly. This is it is not costly, but how it impact the cost thing. I haven't seen. Okay, today we are seeing, okay, this is a cost, but how basically we analyze the cost in this SSMS or in SQL?
So cost is basically whatever work database has to do to get the result of your query. Okay. So let's say you are putting a where condition, you are putting an aggregation, you are putting a lot of other calculations, right? So for each operation will take some memory or some CPU, right? Based on that, cost will be calculated. Okay. And this will give you overall cost here, estimated subtree cost. It is giving you overall cost. So in our case, what happens, since we are using index, right? Cost is less because it needs less CPU, less memory to go through, because it is not going to scan all the table. If it has to scan all the table, right? 100K records, it will take more resources, right? So cost will be more. Now it has to only scan one row, right? It is using index. It is saying index seek. So it is looking at the index and getting me the address of that row. And directly I'm going to that row. So that's why my cost is less. Right?
Okay, it means actually right now we are using community version, but once we move into a licensed version, then the cost basically comes into picture.
Cost is not the money. I'm not talking about money as such. It is not that cost. It is cost of CPU utilization and memory. It is the resource cost, not the money.
Okay. I was thinking, okay, it is like some cost we have to bear.
No. If you say there's estimated CPU cost, right? How much CPU we had to use, IO cost, how much input output data we needed to use to get this query, right? So different kinds of costs are there, operator cost. So if you go here, it will give you overall cost, estimated subtree cost.
This is basically resources or infra cost. Basically.
Right.
Mhm.
right? So you have limited resources. So if you use all the resources, it is not good. The more resources query has to use, more time it will take, right?
Yeah, okay, got it.
Okay.
So we need to scale up or scale down as per the query we are executing then. Let's say we are running a very big query, then we will need more resources, like more CPU cores.
Right,
more
right,
computer. Okay.
right. It will take more resources, definitely. Okay. So to improve the query plan, index is one of the primary thing in database. That if you create index, and index should be created on columns on which you are querying. So whatever where condition you are putting, on that you can create an index. Or let's say you are doing a join, in join columns also you can create index that will help improve the performance. Okay. I want to talk about this lookup also. So what is this lookup? So I told you, right? When I create a non-clustered index, it will go to the index first, get the address, and then do a lookup, right? That's why there is a lookup also. So first it is using the index to get the address, and then it is also doing a lookup on the table, right? Make sense? Now let me do one thing. I will just say select Rn from orders index, where Rn equal to 100, and run this. Now in this case, tell me one thing. Do I need a lookup or not? I'm just selecting Rn. Earlier I was doing select star.
No.
Because it can directly give this Rn value from the index itself, right? This Rn is present in the index because I have created an index on Rn. So if I run this now, see, there is no lookup now. It is an index seek only. There is no lookup. Why? Because this index value is present in index itself, the Rn. Rn is present in the index itself. So why it will go to the table? Not required, right? Making sense?
Yes, Ankit.
Okay. So if I just take another column, let's say customer ID. And I will run this again. See, again it is doing a lookup because customer ID is not present here, right? But that's why the moment it finds the key, and then it will go to the table and do a lookup. Okay. So now let's say you have a requirement, and for some reason you want to include customer ID also into the index, right? Basically, you want to create an index on Rn only, but with the index you want to store the customer ID as well. So there is this option of include as well. Include, and I can give customer ID. I can give multiple columns here. Okay. So along with the index, in the index itself, along with the key, it will store the customer ID as well. Okay. So let me drop and recreate this one. And I will create it again. This time it is taking time because it has to store customer ID as well along with index. When I created just like this, it was fast, right? And customer ID is again a string column. So it is now done. Okay. So let me do a star first. Select a star and display execution plan. It is doing a lookup, right? Because it has to get all the columns, so it has to look up in the table. Now let me do only Rn and customer ID, right? See, there is no lookup now because I stored customer ID also along with index, right? So it is just a index scan, index seek, and we are just reading one row. Estimate number of rows to be read 1, right? So now it all depends on what kind of queries you are running on your table, right? So you created a table and you have some reports. According to your report, you will create the index, right? On which columns the filter will be applied, what columns will be in select. If you think there is only 1 or 2 column in the select, you can include that in the index. So database doesn't have to do a lookup. It will be much faster then, right? See, it is 0.003. Earlier it was 0.006 when it has to do lookup, right? So it is just going to the index and giving you value. It doesn't have to do the lookup. Okay. This is fine, right? Okay. Similar to non-clustered index, you can create a clustered index. If I create a clustered index on this table, it will take time because it has to sort the data, but you can try it later. So if you create a clustered index will be created similar to non-clustered index. It is just that data will be sorted in the disk itself instead of creating a separate structure, right? And you can have only one clustered index and you can have multiple non-clustered index. Any doubt till here?
Ankit,
Okay.
will the index be helpful in range query as well? Means between less than equal to.
Yeah. Yes. Right. Less than equal to. In that also it will help, right? So if we have,
if we do the string search.
Sorry.
If you do the string search with the like operator, will index be helpful in that case as well?
Yeah, so if you have created an index, okay, and you are searching for, let's say, give me name like, right, ANK percentage, right? Still it will help you. If you have a, let's say on customer name, you have an index and you are saying name like ANK percentage, it will help because it knows that initial string will be ANK. But if you do percentage ANK, it will not help, right? Because it can start with anything.
Right.
But if you do this, it will help. Index will help, right? In greater than less than also it will help because let's say you are saying give me order ID less than 400. So it will just skip this part, right? These two nodes, these two branches, it will just go here because it knows less than 400 will go here only, right? So some kind of table scan it will save. So less than equal to between everything will help in index. Okay. Now the only downside of index is your inserts will be slow, right? Why it will be slow? If it is a clustered index, database has to make sure that data is sorted, right? That is one thing. If it is a non-clustered index also, it has to again rebuild the index, right? So let's say you have this 100 here, right? Now you are inserting 5, employee ID 5. So in case of clustered index, it has to make some adjustment, right? Insert row in between, right? Again, if it is a non-clustered index, it has to again take the new value, right? And it has to again take the new value and rebuild the index, full index, right? Sort again and all those things. So what happens when the indexes are there on the table, your inserts will be slow. Okay. So if you have a table where you have a lot of indexes, lots of inserts happening. So one of the way of, this is a very common interview question also, that if you have an index, okay, your inserts will be slow. So what you can do, instead of inserting data and let database rebuild every time and at every insert, you can drop the index, right? So you will have inserts in batch every day. Let's say it is happening at 5 o'clock. So what you will do, you will drop the index, right? Insert your whole data. Let's say you are inserting 100K 1000 records, right? Drop index and create index again once the data is inserted. Because if you don't drop the index, for every insert, it will be rebuilding the index, rebuilding the index. So inserts will be very, very slow. Okay, so you can drop the index. Once the data is inserted, create the index again. That will be much faster. Okay. Okay. Apart from clustered and non-clustered index, you have unique, non-unique index also. So unique index you can create on a column which has a unique value. Okay. If that value is duplicated, you cannot create it. So let's say I'm creating an index on customer ID. Okay. I'm saying create a non-clustered index unique. Unique non-clustered index customers on customer ID. So now my customer ID is repeating in my data. If I try to create this, it is saying created in index statement terminated because a duplicate key was found on the object name orders index, right? So customer name is not unique. So I cannot create a unique index. So I can say non-unique index, right? Or if I don't give it, by default, it will just create a non-unique index itself, right? I don't know if we can give. No, if we don't give, it will be non-unique by default. So if I create just like this, it will be created. Okay. So now let's try to do some search. Okay. Select staff from orders index where. Let's see some data first. Okay, let's say this name. Okay. Where customer name equal to. Okay. Okay, let's see the plan. So it is doing a table scan, right? Okay, I have created on customer ID and I'm trying to, so I'm doing a search on customer name, but there is no index on customer name. I created on customer ID, right? So let's take some customer ID. That's why it is doing a table scan. Customer ID is this one. Okay. So if you see here, let's create an execution plan. So it is saying we have an index seek, right? So it is doing a index search and number of rows to be the 1300. So it is reading a 1300 rows now. Instead of running 100k rows, it is just reading 1300 rows with the help of index. And because I'm doing a star, again, it has to do a lookup. Okay. So if you see how many rows are there in this, there are 1300 rows. And index, using index, it is searching only, it is reading only 1300 rows with the help of index. So even though the values are repeating, it is able to use the index to read all 1300 rows. Making sense? Let's see if I do like, what happens? Will it be able to use or not? Because it depends how many rows are there, right? So if I do this, there are around 14,000 rows. Okay, now 14,000 rows out of 100k rows. Okay. It is able to use index, you see. The number of rows to be read 14,212, and then it has to do a lookup as well. So with the like operation also, it is able to make use of index. Are we good with the indexes?
And in the group operations, if we do a group by something, then it also work.
In group operations, will it use or not index? So we are not searching as such anything in the group operation, right? But let's see. Group by customer ID. Okay. Let's say sum of sales. Yeah, this should be the name. So it is doing a table scan. It is reading all the rows.
But if we specify a particular customer, that's a customer.
Then it will use. Definitely. Yeah. Then it will filter the data first, right?
Okay.
Where customer ID, like we had DB%, right? So it is doing a seek now, right? It is able to use the index seek.
Yeah. Okay.
And then it has to do lookup also, because sales is there in the table, not present in the index. So it has to do lookup as well to get the sales, right? Okay.
Thank you.
Yeah. So indexes are very useful and very common question also in interviews, especially what is the difference between clustered index, non-clustered index. Interviewer will try to confuse you. Can I create multiple clustered index? If not, why? Answer is simple. Physically, I can store data in one way only. I cannot store data by sorting employee ID or sorting employee name both, right? Also, we can create composite indexes, right? I can create index of customer ID, comma customer name, right? So it will be like index will be created on both the columns. So it will be sorted on customer ID first and then customer name, as well as I can give here ascending and then descending, right? So let's create this index. I'll just drop. And okay, so this index is created. So if I say give me customer name, okay, let's remove this. So if you see, it doesn't have to do lookup because our first of all index is on both the columns, right? Index is on both the columns, so it doesn't have to. This customer name is present along with the within the index, so it is not doing a lookup. It is just doing an index seek. Okay, and then I can also put customer name equal to, let's say, like a%, 1%. Here also it is able to make use of index because these both the columns are available, right? Let me use some other thing here where sales is greater than 100. So if you see, it is doing a index scan as well it has to do a lookup, right? So for customer ID filtration, it is able to use the index, right? But again, it has to do lookup because it has to get sales also, and then it will filter on sales. So even though in select I have customer ID, customer name, these both the columns are present in index, right? So ideally it should get everything from the index, right? But because I have to filter on sales as well, so it has to do lookup to get the sales and then filter data on sales, right? So you can try all these things, check the execution plan, it will give you a lot of insights. Okay, and also because see, I have put a query on customer ID and sales. So SQL Server is suggesting me that you can create a non-clustered index on, if you see here, customer ID and sales, it is saying. So he's saying use the create an index on customer ID and sales, then it will be able to do everything on from the index itself. It doesn't have to do lookup. So sometimes SQL Server will also suggest you when you run an execution plan, okay, if you create this index, it will help you in this query, right? So if I create another index, let me create another index, first sales, let's say, and I will say sales ascending, and that's all I have in the query, right? Customer ID and sales. Okay, so let me create another non-clustered index. Okay, so this is created now. So if I do this, see, it doesn't have to do a lookup. It is just doing a index scan, index seek. right? Okay, you can play with indexes and let me know if you have any doubts. Okay, very important topic. So you make sure you try some clustered index, create some non-clustered index, see what is happening, what indexes are getting created on the table, right? By going here, constraint, you will see all the indexes here in the index, right? So let me refresh it. There's some problem in my SQL Server today. It is not showing me for some reason, but that's fine. It is not showing because I'm doing in master actually. Okay, I got it. Okay, I'm doing all this thing in master data set. I didn't realize. Tables. And there will be orders index. Yeah, okay. Yeah, it is showing all three indexes. So we created three indexes here, right? Non-clustered, all three on customer ID sales, and on row number, right? So you can see all the indexes. You can see in the action which indexes are getting used. So it will show you which indexes are getting used. You can come here and check. And yeah, very helpful, very helpful. Do try different queries. Do try different queries by different putting different indexes. And if you have any doubts, we can discuss in next class. Okay. I want to discuss one more topic. Are we good here on the indexes so far?
Just one small doubt.
Yes.
On non-clustered index,
Mm-hmm.
so if there are duplicate values, will
Right.
the address be same, assigned same,
No.
or is it like
It will be
different
different.
address?
It will be different, right? How can be two rows have the same address, right?
Hmm.
Each row is a different address. So if you have two Ankit, there will be different address, and in the clustered index also you will have two Ankit and the address for both the Ankits.
Okay, so that we can say conclude that number of addresses will be equal to number of rows in our tables or on
Right,
the column.
right. Each row is a different address, each row.
Okay, got it.
Yeah, it doesn't matter it is duplicate row, because in the disk it will be placed in some location, right? And the next row will be in some location. How can the address be same of two location? It will be different, right?
Okay.
Yeah.
That's all. Thank you.
Yeah. Okay. So
Ankit,
there is one important thing about how to. Yeah. Go ahead.
sorry, I was just saying, sorry to cut you.
Hello.
So the non-clustered index is kind of a unique index. I mean, what was the example for non-unique index?
Non-unique index, like we have this ID, right? Row number, which is unique. So it cannot repeat. So your primary key cannot have duplicate, right?
Right.
So when a clustered index is created, it is by default unique index because primary key cannot duplicate. Okay. Okay. But if you want to create a unique index, you can just specify non-clustered unique index, right? Unique. So in this case, if you have a duplicate on this, it will throw you an error that there is a duplicate.
Oh, okay. Okay.
If the values are unique, then it will create a unique non-clustered index.
Okay.
Also,
But
unique cluster.
I could create a.
Yeah. Go ahead.
I could create a non-unique, non-clustered index on, let's say,
so,
first name. First name could be.
Yeah, when you don't give anything, it is by default non-unique.
Okay.
So these are all non-unique. If you see, whatever we created are all non-unique.
Got you. Yeah. Thanks.
Yeah. Yeah. And also, if it is a unique index, definitely it will be faster because it knows there's no duplicate, right? The moment it finds Ankit, it will just give you. It will not look for next Ankit.
Yeah.
Right?
Yeah.
Because it knows there's a unique value. The moment it gets Ankit, that's it. It will stop. It will not even look at the next row. So it will be little faster, unique index than non-unique index. Okay.
Got it. Makes sense. Yeah.
But we don't have a control over it. It depends on data, right? If data has duplicates, we cannot create a unique index, right? So yeah. Okay. We'll talk about how to delete duplicates. So we talked about delete query, right? Simple delete query and with join and update. But there's a common interview question, and in real life also you will encounter this, right? If there are duplicates in the table, how do you delete duplicates? Okay. So let me again use employee table for that. Okay. So we have employee ID, employee name. Let's say 2 columns only for now. Okay. So I inserted a data 1, employee name Ankit. Okay. Again 2, Rahul, 3, Vivek. Okay. Now let's say by mistake you don't have a can you go on mute, please, guys? Thank you. Okay, so you have employee ID, employee name. Okay, and let's say you don't have a primary key or something which will stop the duplicate values, right? You inserted 1 again by mistake, or you are running an ETL, it ran 2 times, whatever is the reason. Somehow this employee ID 1 also got inserted, maybe with same name or different name, right? Doesn't matter, right? Let's say with different name, but your employee ID should be unique, right? They cannot be duplicates, right? How do you delete it? Okay. So generally in every table we have a create time column. Okay. So you will have a create time column. Let's say the time of this is 2022 12 22, and then I have 10:40 00. Okay. So at this time this record was inserted. Now another record, this also inserted in some time, right? Timestamp cannot be same, right? For each of them timestamp may be different. When it got inserted, it was 10, let's say 01 here. Some differences there. 41. Okay. So if you have a column in your table which can differentiate between these 2 records, right? Let's say they are exact duplicates. Now looking at this, right, I cannot delete 1 record. If I say employee ID equal to 1, it will remove both the rows. I just want to delete 1 row, right? I want to remove duplicate rows. So 1 I have to keep it. So let's say if this column is not there, I have just this column, these 2 columns. And if I say employee ID equal to 1, it will delete all the records. I will say delete from employee where employee ID equal to 1. I was able to identify 1 is a duplicate. I will tell you how. But if I run this, both the records will be deleted. Again, if I say delete from employee where employee name equal to Ankit, again it will delete both the records, which is a problem, right? So we should have a column which can differentiate between 2 rows. So let's say create time is different. If create time is different, I can identify one of the records and delete it. Okay. Let's see this in action, and we will see if we don't have any column like this, how do we deal with it? Okay, so I'll go to the SQL Server again, and let's create another table. Create table emp dope. Okay, so emp id and emp name. Okay, 20. And we have create time. Okay, let's say date time it is, and we are going to create this table now. Okay, and let's insert some records. Insert into pdope values 1 complete, and let's give some time 2 12 22 10 40 01. Okay. We should be able to do it. Okay. Let's insert another record to Vivek. And let's keep it same time. That's fine. And then 3 Rahul 41. Okay. And now I'm going to, yeah.
By default, we are taking system time whenever we are inserting any record in the database, right?
Right. I can use current data also. That is also fine. Current time. Yeah.
Thank you.
Okay. Yeah. I can use sysdate parameter, but for now, let me create a duplicate here, but I will change the time. Okay. Okay. Let's see the data now. So sysdate also, if you use, you will get a different timestamp also always, right? Let's start from EMP. So you should use sysdate only whenever you are inserting the record. So what will happen? Every time you will have a new timestamp, right? Okay. So we have this table now where we have 1, 2, 1. So we have this duplicate here. Okay. And I want to delete the duplicate. So I will first identify, do I have the duplicates or not? And if they are duplicates, I want to delete one of the record, right? And my create time is different for these two records. Okay. So first we have to identify duplicates. Okay. So my primary key is employee ID. I mean, I should not have duplicates on employee ID. If employee ID is repeating, I'm saying that is a duplicate. Okay. So how I will identify first which employee ID is a duplicate? Can someone tell me?
By grouping them.
Yeah. So I will do a group by. And what else I will do after doing group by?
Group by
Being count of star greater than.
having count ID greater than 1.
Right. Count of employee ID, or I can just do count star. Right, greater than 1. So it will give me all the employee IDs. So let's say I have hundreds, thousands of records. It will give only those employee IDs which are duplicates, which have more than one record. Right. So this way I have identified that employee ID I have to delete. Okay. So if I do this now, delete from employee dope. From dope where EMP underscore ID in this. Right. So what it will do? It will delete both the records, isn't it? Let me do this. See, 2 rows affected. So I will have only 1 row now. So that this is the problem if I use this approach, right? Right. So this is the problem. I cannot use this approach, right? Or both the Ankits are deleted. I want at least one Ankit, right? So let me use sysdate this time. We have sysdate only here. Get date, sorry, get date. Get date. Okay. Okay, so if I see this now. Okay, so I have something 828. Now let me insert one more record. And I do this. So I have 2 records, if you see, 828 and 829. So timestamp is different. So it is always you should use get date if you have a create time kind of column in your table. Okay, so for every record, they will be different. Now what I want to do, I want to remove a duplicate. Now it is up to you which one you want to delete, or if there is some business use case or something. So you have to first decide you want to delete the earlier record or the later record, right? You want to record which was inserted first or which was inserted later. So we can take a call, right? Let's say I'm taking a call that I want to delete the earlier record, which was inserted earlier. Okay. So what I will do, along with employee ID, I will take minimum of create time. Right, as create time. Right. So now if I run this query, along with employee ID, I will get the time also for which I need to delete the record, right? So now I got this time as well, right? That I want to delete record for employee ID 1, but create time should be this one, right? Now I have the information to uniquely identify a record and I can delete it, right? Now in most of the database, you can do this where employee ID, comma, create time in. So you can give a tuple like this and you can just delete it. So it will just look at the tuple value, employee ID and create time, and it will delete. But in SQL Server, this doesn't work. You cannot give this 2 columns in where clause in a tuple, right? But in most of the 90% all the databases, you can give it. The SQL Server has this limitation. So you cannot give it. So we will have to use join, right? Yesterday we discussed about join, how to delete data using a join. So I'll use a join here. Okay. So I'll say delete employee dup norm, let's say E, right? And then just remove. Oh, sorry. Okay. And I will say in a join this query, let's say it is D on E dot employee underscore ID equal to D dot employee underscore ID, right? And E dot create underscore time equal to D dot create right? I will do this. So what will happen now? It will just join on this on the minimum create time for this employee ID wherever duplicates are there and just delete that record because I'm doing an inner join, right? If I run this now, one row affected. So only one row is deleted, not both the rows, right? Is this part clear, guys? Very important. You need to understand how it is working, why we needed the create time column. Because if I don't have anything to uniquely identify a row, I cannot delete a single row, right? I will end up deleting both the rows, right? Any doubts here?
Sir, can we do here with the help of window function?
So with the help of window function, so what happens? You want to delete on a table, right? So window function will create a CT. Again, in SQL Server, it works, but I don't want to tell you that is not a standard way. Okay. So you can create a CT, get the row number, and you can say row number equal to 1. But when you are deleting a data, you should put a filter condition on a column in a table, right? You cannot put a filter condition on row number, right? Row number is a column we created. It is not present in the table. So how can you use that? Somehow in SQL Server it works, but whenever you are deleting, you have to give a filter on a column which is present in the table. Okay. So when you are deleting the data, you have to put a filter on a column which is present in the table. Okay. Okay. So the problem here is that, so this is fine. So this is fine. Now the problem comes if I don't have a column which uniquely identifies it, right? So again, if I look at it here, so I have 2 rows now again with Ankit. Let's say create time column is not there at all. Okay. Let's say create time column is not there. Just I want to delete, still I want to delete one record, right? Just forget this is there. How can I do that? It is not possible, right? Not at all possible. Now in Oracle, particularly in Oracle, there is a pseudo column called row underscore ID. Okay. So row underscore ID is kind of an address of each row. We talked about the address, right? So in Oracle, that address is present in row underscore ID column. So what happens now? That row underscore ID we can use in our query to delete the data, right? When you do select star from table, that row underscore ID will not be visible. But here what you can do, you can say minimum of row underscore ID. So it will give you only one ID. Each row will have different ID, right? So you can just use that row underscore ID to delete the data. But in other databases, that row ID is not there at all. So you cannot uniquely identify a row. So in that case, one option is you can just take a backup of this table, do a distinct, because these are pure duplicates, right? So if you get you do a distinct, you will get the unique records, and then you can insert it into the original table. Let's do that. So what I will do, let me create one more table, do one, and I will just remove this part. Okay. And let's do this, do one. One more. Yeah, two. And again, I will do one. Okay, so now I have pure duplicate, and there is no way I can identify one row, right? If I identify one Ankit is there, and both the records will be deleted. Okay, so what I can do, I can take a backup of this. So select, I can take a backup of distinct values. So I will say distinct. So if I do a distinct star, what will happen? What is taking so long? Okay, if I do a distinct again, they are just, yeah, we can do group by also, distinct also, right? So if you see, we are getting 2 rows now, but in our table we have 3 rows. So what I can do, I can just take it into another table, into employee to one backup, right? So we have the 2 rows now. So this table has the from distinct value, because we had pure duplicates, so we were able to do this, right? We were able to do this. Now what we can do, we can just delete or truncate data from the original table. Truncate table, employee to one, right? So all the data will be gone here, and then I can just insert back from the backup table. So in that way, I don't have duplicates now in my original table, right? So if I run this now, there will be 2 rows. So this is another way of removing duplicates when you don't have any other key which can uniquely identify a record. Now for uniquely identification, it is not necessary you have create time. You can have any other column, right? Some name column or city is different. Something is different for those, right? You can use any of the column. But let's say you have pure duplicates. In that case, you cannot do much until and unless you are working on Oracle where you have row ID concept. So you will have to take a backup of the table with the distinct records, truncate data from the original table, and then insert it again, right? All good, guys?
Yes, thank you. So just to clarify, in case, I mean, when you say the uniquely identification, if I have a last name, which is again, I mean, if that distinguishes the records,
Right.
I cannot take backup, and I mean that doesn't work there, right?
If
I mean,
last
it was
name is different, right?
Yeah.
Yeah, so you can, instead of create time, you can use last name, right?
Yeah,
And join
yeah.
last name. Yeah.
Sense.
Okay.
Ankit, I have one question for you.
Mm-hmm.
The logic that we have for the first one and the delete, where we have the inner join,
Yeah.
Just in case if we have an employee who has more than 2 duplicates, then in that scenario, this might be a little flawed, or we would have to like do something like a not in max of create time in that
Right.
scenario.
Good question. Good question. So the question is, let me explain it to everyone. That what if we have multiple duplicates? So let's go to the employee dup 1. Sorry, let me use it here. Employee dup only, and we have Ankit, and we have one more record, right? Okay, so if I do this, okay, we have to have get it. In the second case, there is no issue, right? We are doing a distinct. But here, if we have to
Yeah,
do it, how
right.
we right? Let me show you. A very good question. I forgot to cover that. Yeah. From employee dup. Okay, so currently if you see there are 3 duplicates. Okay, so I have to, if I have to delete it, what I will have to do? Let's see. So first I have to, if I delete this, what will happen? Minimum create time will be deleted, right? So if I execute it, one row is deleted, but still one duplicate is there, right? So I will have to use this statement multiple times. If I run it again, then it will again delete one more row, right? So see, right? So I will have to do multiple times, and I don't know how many duplicates are there. Maybe 10 duplicates are there, right? I will have to run it 10 times. So what is the other alternative? Okay, let me create duplicates again, and then I'm going to show you. Okay, so still we have only 2. Let me put one more. So now we have 3 records. Okay, and I don't want to run this statement 2 times. I just want to run 1 time. Okay, so what I can do? So one thing what I can do is, instead of identifying which one I need to delete, I can identify which one I need to keep. Okay, so I will say I want to keep the latest one. Okay, right? Also, I will just remove this condition. Okay, by doing this, I am saying don't delete these records. Right? So what I'm saying, I'll just change the condition, but ultimately what I'm saying, don't delete these records. So whatever duplicates are not there, for them, one record is there, that will come. And for whatever duplicates are there, I will get the maximum create time, right? So apart from whatever these 2 records, whatever is there, just delete it, right? That way, I will be able to delete those two employee ID 1 together, right? Is this understood what I'm trying to do?
Right. Yeah.
Yeah, instead of identifying what I have to delete, I am identifying what I don't have to delete. Okay. Now I will do a left join here. Okay. And I will say where. Okay. I will say where. Can you tell me what condition I should put to delete records which are not present here? Can someone tell me where condition?
Where employee ID not in the left table.
Not in left table, this table.
Yes.
So what I have to do? So employee ID is there. Create time. I mean, so what will happen? What will happen, right? The for those 2 records, this will be coming null, right? Isn't it?
It shouldn't be available on the right table, right?
Right. So let me do one thing. Instead of delete, I will just run a select. So it will be clear. Select star from this. Okay. What is happening? For these records, this is coming null. From right table, data is not coming, right? Because the join is on employee ID and create time, right?
Where employee ID is not null, is null.
Is null from right table. D.employee ID is null, right?
Yeah.
If I say where, so it is important to say D.employee ID, right?
Right.
Because E.employee ID is always there, right? Is null. So if I run this, I will get just 2 records, which we need to delete. right? These two I need to delete, isn't it? Isn't it?
Right, yeah, that's perfect. Yeah.
Right. So I'll just use a delete here. Right, that's it. Now if I do select a star from employee dup, I will have 2 records. So at once only, so I just reverse the condition. Instead of what I need to delete, I identify what I don't need to delete, and everything else I will just delete it. Okay, and all these things are easy in other databases. You can just use in and not in, like I was saying, right? So similar to in, we can use not in and write this in subquery. But in SQL Server, again, you have to use left join and this condition.
But comparing to the performance scenario, not in would be much slower compared to a joint, right?
No, in
So-
delete scenario, it will be fine. So if you see here, we have to do a join and where condition as well, right? So if you are able to use directly not in for delete, it will be faster, I guess. And it will be simpler also to understand. This makes little complex things, right?
Right, yeah.
Yeah.
We can use non-exist, Roy.
No, yeah, right. Very good. We can use not exist. Yeah. We can use not exist as well.
Okay.
Yeah. Okay, so try with not exist also later when you have time. And yeah, try deleting duplicates with both the scenarios. Very, very important. Not just from interview point of view, in your day-to-day work, you will encounter this, that you have to delete duplicates from a table. So you should have a bunch of options with you that how you can delete, right? Okay, we are already over time today. But I think we are finishing all the SQL topics. We will have a Tableau session tomorrow. So I will cover all the fundamentals of Tableau. So if you are interested, do join in learning Tableau. Many of you might already know. So if you want to skip, you can skip. And if you want to join, you can join. I will just try to relate it with SQL, how Tableau works. So you might learn something even if you don't, even if you know Tableau. Okay. And then during the weekend, I will send the project so that you guys can spend some time. And then next week, we will discuss the project. Okay. Okay, guys. Thank you. Have a good day. See you all tomorrow.
Thank you.
Thank
Ankit,
you.
I just want to add one last question for you.
Yeah.
Would you know if there is any place where we can refer to some documentation to be able to understand the execution plans a little better?
I can share that. Yeah. You want to? Yeah, I can share the document or some video, whatever I find. Go to the source. I will share.
Yeah, because when it comes to
Okay.
complex queries with a lot of joins, it gets a little difficult to understand how we can make it easier.
Right. Sure. I'll just find it out and share.
Yeah, thank you so much.
Ankit,
Yeah.
one more thing, just wanted to confirm, like, what is the, I mean, just if we want to test our, ability to write a queries, or if we want to clear some exam, what is the best recommended exam to see how good we are for a senior developer, let's say?
For the SQL, right?
Yeah.
Online tests. I'm not sure.
I mean, some certificates that if we want to do certified, let's say, SQL
So the
developer or something.
certifications and all which mostly are there are not on your SQL writing capability. It will be maybe basic SQL, but all the certification, Oracle certification and SQL Server certification are more about system, performance and the basic theoretical knowledge, more about theoretical knowledge, not about SQL writing ability. Okay. But you can always practice from different HackerRank and different websites are there, right? You can practice from their lead code, data demo. I will see if there is some SQL test as such, which we can.
Some gold certified or something that they called. I mean, I'm really not sure what exactly was that. I just was reading through one of your LinkedIn post. Somebody had commented, I guess.
Yeah, that is all HackerRank and HackerRank. So
Okay.
Yeah, you the more question you solve, you will get some rank, silver, bronze, gold, based on the number of questions you have solved on HackerRank.
Okay.
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 So I don't know if they have the test also, a time-based test. I can check and provide the details, but I've never encountered as such time-based test on HackerRank openly. But through the companies, they customize it and they provide to different companies so that they can test the candidates. But for
Okay.
individual users, I will check if we can have some test. Yeah.
Sure. Yeah. Thank you.
Okay. Thank you. Have a good day.
Thanks. Good day. Bye bye.
Thank you.